Very good. Okay, should be start recording now. Uh, if you have downloaded this file, okay, so this file is capturing a flow. Okay, I use NC. Okay, and particularly I use another tools. That tools I specially designed it for my demo purpose. It will only drop one packet. Okay, it will skip the speed handshake and randomly choose one packet to drop. Okay, so this is my special program, and later on, don't be afraid that this is so horrible. The programming itself is very simple. You will anything how to program this kind of capture tools, capturing it, drop any packet that you want, and actually this is a firewall capability. Now, what I'm going to talk about is how to trace a Wireshark file. By looking at a Wireshark file, immediately you will find the first packet with, I don't have a laser here. I don't know why I was still with laser. The SYN, okay, can you see the cursor? Okay, so the cursor SYN is the same packet, right? So I tell you that I will capture TCP only. So you won't find ICMP, UDP, or whatever other P's there. Okay, so this SYN, okay, when you open the transport layer protocol folder, when you open it, you will see all the details. By the way, later on, we will also understand what is this IP header. But in the meantime, we can safely skip it, the IP header. And let me tell you what is my current setting. My current setting of it is there is two machines. Okay, these two machines is originally placed in my office. So these two IP addresses and the port numbers. This is the server. I use the port number 44300. Okay, so you will see that the flow with our source, okay, going to the destination. Let me say the first guy is from the client. The client go to connect something, and then you will find that there is a number here. Yeah, the highlight itself is ugly. Okay, so I avoid it. So it's called sequence number 0. The sequence number, but it is contrary to what I said in the lecture, right? In the lecture, I said that sequence number is supposed to be a random number. Okay, supposed to be random number, but it says that it's 0. Now, if you have Wireshark, okay, you can do the same in the screen together. So you can go to preference. You go to preference. Wow, what happened here? Yeah, I can enlarge it. Yeah, okay. It's very ugly. No problem. Okay, I know that this is a protocol. This is protocol. Yeah, I do the practice. So I search for TCP by typing TCP. Okay, can you see that TCP appear here? Okay, then it is all the setting for TCP. Now look for one setting called relative sequence number. Okay, so it's called relative sequence number. We move that check, okay, and choose apply and okay. Then immediately you will find the sequence number no longer is 0 from the start. Okay, come on. Okay. No longer 0, it becomes non-zero, a very huge number. Actually, this is random generated number. And look at the second packet. The sequence number also another random number. Okay, but we are not computer. We are not good at looking at big numbers. So we better turn the option off. Showing the true number is not good, so I turn off the true number. So here, turn it off. Okay, so what are the others thing? Other things are like analyze TCP sequence number, this guy. So it's actually know how to detect lost packet, out of order packet, what is the retransmission, what kind of retransmission it is. Okay, so it will highlight it in the trace file, okay, for you. But if you uncheck it, those highlights will all gone. Okay, so we better keep this enable here. Okay, so we enable the relative sequence number so that you understand. Oh, I didn't press apply. Yeah, okay. So you can refer to the lecture notes. The lecture notes will say that the first sequence number is randomly generated, and in here it tell you that this is a 0. Okay. Now 0 means that the sequence doesn't really start. Usually, when the sequence really start, it will go through a three-way handshake. So the second sequence, the second. So let me write down the sequence number here so that you can know how to trace it. The sequence is 1. While the ACK is, oh no, sorry, it's not 1, it's 0. 0. Okay, while our ACK value for the first packet is not here, right? It's not here because the report know that the ACK is not important. The ACK why is not important? Because the first flow, the first packet identify the first direction from the client to the server. So there is no other flow coming out yet. So that ACK is actually mean nothing. So what happened inside the real traffic? We can look at the real traffic in this part, okay, in the layer part. Now click on the sequence number, and believe in me, okay, the highlight part, the 4 bytes here represent the sequence number, and the next 4 bytes is the ACK. So in the real traffic, it is 0. Remember, it is 0. It means that it is not important. Now, what's next? The next guy. The next guy, the second packet. So from where to where? Now you know that it is from the client to from the server for the first packet. So for the second packet, it should be the response. It should be this guy is a sync packet. So the next guy should be a sync act. Okay, should be a sync act. So let's see. Here is already a highlight for you that the flag is turned on in sync act. No problem. Now, how about the sequence number? The sequence number is originally is another random number, and I showed you before. But what is the ACK? The ACK now become 1. 1 means that is originally say that, hey, please give me what? Give me the spike offset 1 for me. It means something like that. Okay? But the first guy, okay, the first guy say that my sequence is 0. Sequence 0 without any data. So the next packet acknowledging this packet should be also saying ACK number 0 because of the data link 0. But I said it before, you can refer to the lecture notes. I don't want to switch the screen. So you will find that there is special rule for the sync act. Sync act will acknowledge the same plus 1. Okay? So here it said that it become 1, and so forth for the last ACK. Then eventually, when you look at every trace file, it already do the calculation for you that the both relative sequence and ACK for the last packet will both 1. So this is not very important. What is more important is we have to trace in this file. I said that I dropped 1 packet in this file. So where is exactly that the drop happened? Now let's trace the packet now. Okay, tell me. Oh, maybe I never record that. Also here. So the sync act is here. The third guy is the act. Okay. And the sequence number is 1. ACK is also 1. Okay. So the fourth guy. The fourth guy. So who can tell me what is the direction? What is the direction for the fourth guy? The fourth guy. Look at the IPs. Look at the port number. Is it from the client to the server or is the server to the client? Now remember, after you have, I know there is still 10 groups didn't submit their work, but you are already writing that assignment, right? You already know one thing for sure. After you connect, who sent the first data doesn't mean anything, right? It can have after connection, the server sent the first packet, right? Or the client sent the first packet. It doesn't matter. Okay, it depends on how you write the program. Now, here, who can tell me which direction? Fourth packet. So I see both directions. Yeah. Client to server, or server to client. Okay, so some others are still in quantum state. Okay, so you love both answers. So it is a client to server. Okay, client to server. So it should be this part. So it is data packet, supposed to be data packet. I just write it down. I don't know whether it is a data packet or a plain ACK. I don't know. So let's check. How can we identify this packet is a data packet or plain ACK? Very simple. Look at its data length. Look at its data length. So where is the data length? In the trace file. I don't want to highlight this, but I want you to focus at this row. Okay? Yeah, but the highlight of the Mac machine sucks. Okay? Yeah, what is data length here? How many bytes? 0? No. What is the length? 1,000 something, right? 1,000 something. It is 1448. 1448. So it is a data packet. Sequence number. I don't need to look at the trace file. I know it is 1. Because this is the first byte that I sent. Now remember the first byte that I sent. So the first data offset is always 1 in a relative sense. Okay? So it's always 1, so I don't need to look at it. And the length is 1448. Okay? Usually you will see this 1448 in many trace file because it's supposed to be the, possibly largest data payload for each infinite-based packet. Okay, infinite is for infinite there is a payload size. Okay, and the payload size later on I will have the math, very simple equations. Okay, to say that actually that's 1,500 bytes will compose of the data, 2 headers, TCP and IP, or you use a UDP, okay? But in our communication here is TCP, okay? So IP, that means a 1500 minus the IP header minus the TCP header, then we will usually send out 1448, okay? And later on, I will tell you how to boost the TCP flow. Right? Come on. What? Oh, 1 hour battery. What? It's supposed to be new battery. Okay. So the length is like this. So yeah, let me tell you what is the data. The data is stupid, okay? Because I use a program to generate it, I will send only one for 1,448 times, okay? Or once, okay? No problem. So what is the 5th packet? The 5th packet, what is that? Can you tell me? Which direction? Plain ACK or data? That means what? Client to server or server to client? Client to server. So the sequence number is, yeah, you can see it there. It's already out there. Here is supposed to be the last offset plus the last length. So the last offset is says 1. And for starting from 1, it will send out 1448 bytes. So the next offset, we will start with another offset. Okay? Start with another offset should be 1 plus 1448. It should be 1449. Okay? Oh, I run out of space here. It should be 1449. Now don't be so skeptical about, hey, do I do I have a back tracing or I delete some of the packet? No. This is the TCP characteristic. TCP, you still remember it? It had a mode called pipeline, right? Okay. Whenever I say keyword, yeah, pipeline. Okay. So it can do sending out packets, many packets. Many packets at the same time. Okay. So you will see that it sends out two packets together. Okay. Now what's next for the sixth one? For the sixth one, what is the direction? Data or plain ACK? Yeah, I see some. Yeah, what is that? What is the direction? Is it a with ACK or data? What is the data length? Data length 1? What? What is the data length? 0. And what is the direction? Yeah, in the reverse, right? Reverse of the previous direction. Okay, so it's data length 0. The sixth one. Data length 0. Okay? Now, you understand that I sent out two packets, but whether this packet is acknowledging this packet or this packet, we don't know, right? We don't know. So this is about the acknowledgement number now. Look at the acknowledgement number. Tell me whether it is a reply to the fourth or the fifth packet. What is the ACK number? It's 1449. So still remember what is the meaning of the TCP ACK? TCP ACK meaning means I want you to give me the next packet with that offset. I expect that offset. Okay? So now it said that I expect 1449 offset. So which packet does it require? Which one? The thing is the fourth one. Okay, how about the fifth? The fifth, not yet, right? Not yet. So it is ACK to number 4. ACK to number 4. How about the seventh packet? Yeah, seventh packet. When I not highlighting it, you will see that it is in red. Okay, in red color in dark background. So the Wireshark finds something wrong. Wireshark finds something wrong. Let's see what is the thing. It is wrong. Now it's also highlighted here. It said that some big problem up here. Now when you see some trace like this, it means usually either one of the two, packet corruption or packet loss. Okay. Now let's look at that. And let me write down the data first. It is a data packet. The sequence number is what? 4349. 43449 or 45. Okay. And the length, yeah, I can guarantee you that it is 1449. 1448. Can you guess what is it? What happened here? Why is highlight? Why is highlight? Any idea? Yeah, actually I should turn it off. I can turn off this option. Okay, so that you can guess what it is. Let me turn off the option. Open it. TCP. Don't analyze it. Apply. Okay. Good. Yeah, the warning is gone. Okay. So you cannot see the error message now. What happened? Yeah, I removed the error message. It's yeah, the sequence number. Yeah, yeah, I accidentally touched it. CP relative sequence number. Yes, true. What happened? Apply. Okay. Yeah. Yeah, it's bundled together. Sucks. Okay, so let you know what it is. Come on, apply. Okay, so you can see yeah, it is says something very strange there. Okay, there is a warning. If you can see it clearly, it says the TCP previous segment not captured. Okay, so what is the problem here? What is the problem? It's supposed to be there is a packet loss. There is a packet loss. Why I can be so sure? Why I can be so sure? If there is no packet loss, okay, so I add the imaginary packet here. Okay, so usually imaginary things with question marks. Okay, so it will be a data packet. If it is still there, it doesn't lost. It didn't miss being filtered by me. The sequence number should be some value. Okay, and I can guarantee you that every packet I generated is of length 1448. Okay, so what should be that number? If this imaginary packet is still here, it is. I can guarantee you that this is the packet that I kick it out. I have a filter program. That when the filter program goes through my filter, okay, I choose that packet. Hey, you go to that. Okay, what should be that number? How can I know? It's very simple. Very, very simple. What is that? First digit, 2. Second digit, actually, I'm not good at it. It's supposed to be this number. It's supposed to be this number. How can I know? How can I know? First of all, the fifth packet means the second data. The second data starts with the offset 1449. Okay, second data starts with offset 1449. And suppose that all bytes will be delivered, then the next byte that I will expect to send will be 1449 plus 1448. Together form 2897. Okay? Form 2897. So I can write it down. It's supposed to be 1449 plus 1448. Okay? But sorry, this guy is gone. This guy is being dropped by me. I set up a program. It's being dropped here. Now, what happened to this guy? This guy, remember, we will cache it. We will cache it on the server. Okay? And the server will also have a similar logic. It looks at the previous packet, no gaps. And suddenly, you send me the 7-1 and introduce me a gap. Okay? Introduce a gap, so the ACK, I mean the 7 packet, and now it is the 8 packet, the ACK number will be a little bit different. The ACK number will be a little bit strange. Okay, so what is the ACK number? It is 2897, a little bit different. Why? Length is 0, ACK is what? 2897. Okay, 2897. So it's actually none of the business of the service guy. It's actually an only English guy. is acknowledging another one. Which one? This guy is not acknowledging the seventh guy. Still remember, that guy is acknowledging the fourth packet. How about the fifth one? You didn't acknowledge it, right? So check whether this 2897 is acknowledging the fifth guy. Is it? If it is, that means that his ACK plus his length will identical to this number. Is it identical? Yeah, you use your calculator, all people have phone here. So add two numbers together, you will find this number. Okay? So actually the eighth one is not acknowledging the seventh one. So I say that it is a strange trace here. So it's not 7, it is the fifth one. Okay, it is acknowledging the fifth one. Now, how about the ninth packet? Ninth packet, yeah, very interesting. What is the direction of the ninth packet? Now, this is a very typical realistic TCP packet flow. Okay, don't be surprised, it's like that. What is the direction? Client to server, right? Client to server. So, that means that the client don't know that he should shut up. Okay, he don't know that he should shut up, and because of the pipeline feature of TCP, is still firing out packet. Firing out packet. So what is the sequence number? Oh, 5793. 5793. Length 1448. Is it the same sequence? Let's check. It's supposed to be 4345 plus 1448. Good. So that means there is no gap. No gap there. It means that it's continued without any losing of the data. Now, how about the 10th packet? The 10th packet is being highlighted. The 10th packet is being highlighted. So what is the keyword? The keyword is, now look at 10th packet. It says, yeah, let me read it out for you. It says TCP DUP, that means duplicate ACK. So it's known that there's duplicate ACK now. So what is the meaning of duplicate ACK? Let me write it down first. It says the acknowledgement number is 2897. Length is 0. ACK 2897. So this is a 2, number 5. Number 5. So how about this guy? The 10th packet. Okay? So actually the 10th packet, it is acknowledging to someone, okay, but the sequence number, the ACK number is duplicated ACK number with the previous guy. Still remember why it's like that? It sent out duplicate ACK because it detects packet loss. It detected there is a gap in the TCP flow. So it keep on telling you that, hey, the packet that I expect with the sequence number, it should be this guy. Okay? It is not other guys. So it's actually hints. There's a hint that it is acknowledging data packet number 7. Right? There is a hint. We can look for the hints. And the hint is because of the selective acknowledgement. Still remember, I talked about selective acknowledgement. Do I have the lecture notes here? Let me check. Let me look for the. Yeah, where's my finder? Let me look for the notes first. Wait a moment. Lecture notes. Okay. Selective acknowledgement. Okay, here you are. So the selective acknowledgement is to tell the other side that there is a gap. And I will tell you what are the data that I already cached. So here I cache from 11 to 15 byte inclusively in this slice. Now, how about in the real trace? In the real trace, it's actually something like this. Now, there is a bunch of things that is being closed here. Now, what is the place that I will open? Still remember where is the selective acknowledgement data? It is in the TCP option. So I will open the TCP option. There's a bunch of things. I don't know what it says. Yeah, what is a bunch of low op? Yeah, it's not computer architecture course. It's that low op. Okay. Yeah, some timestamp, or actually the timestamp is for other use. Now I find a keyword that I know. SACK, the last one. SACK. Now open up the SACK. It will tell you that left edge and right edge. It means that the two numbers that I have, the data that are being cached as offset number. So the offset that I have cached is 4345 up to 5793. Okay? Now look at my Excel. Yeah, that's why I have an Excel always prepared there. Okay. Move it up. So can you see that? The here is not inclusive. Yeah, forget about this. So this is including the left edge is 4345. Okay, supposed to be the data that I sent, and the server will tell me that. Undo. The server actually is telling me that the SACK port is telling me that from 4345 to this byte is being cached. It's being cached in the server. Okay, so it is about the SACK. Now, what happened next? What happened next is the 11 packet. So what is the 11 packet? Because of the TCP pipeline, it won't stop. Okay, it know that I can send something safely. I'm not aware of the packet loss. Okay, it will continue with the pipeline. So the 11 one is also a data packet. When you know a data packet, it means that it's from the client to the server. So let me write down 11.1 data. It is a sequence. What is the sequence number? It is 7241. 7241. And the length again is 1448. Okay, so is there any gap? Let's check with the calculator. 5793 plus 1448. Okay, no gap. No gap. There is no gap from the previous data packet number 9. Data packet number 9 and 11 are stay together. There is no gap in the CCP sequence. Now, how about the 12th one? Okay. Now, the 12th one is also highlighted here. It's considered to be the second duplicated acknowledgement. The second duplicated acknowledgement also tell you that, hey, the sequence number that I expect is 2897. Still 2897. So let me copy and paste this guy here. But how about the SACK sequence? Okay, that packet, okay, is supposed, the previous packet is supposed to be responding packet number 7. So I expect that it is responding to packet number 9, right? Supposed to be like that. Now let's check. How can I check? If it is responding to packet number 9, that means that the SACK content, the SACK will tell me that I already cached more data. And the new part of data I have a cache is including all the data range inclusively embraced by the packet 9. Now let's check whether it's the truth. Look at the SACK part. It's from 4345 to 7241. Let me update it to 7241. See? What is the meaning? What is the difference between the 10th and the 12th packet? They carry the same ACK, but the SACK part different. They become different because they tell the difference tells you that I cache more data. There are more data cached in the server side. Okay, so this is about a 12 packet. Now how about 13? Yeah, 13. When you look at the length, okay, you can see the length there. When you look at the length, you know that it's data packet. Now, because of the pipeline, it's continue. It's sending just like crazy. It won't stop. Okay, so the sequence number is 8689. 8689. Okay, so let's check whether this sequence has a gap or not. Plus 4. Okay, no problem. So it's stay close together. Very good. How about the 14th? Yeah, here. The 14th, if the is supposed to be the last duplicated acknowledgement. Why? I will tell you that if there are triple duplicate ACK, it will trigger fast switch transmission. Okay, so it will be the last duplicated ACK. And because it is a control experiment done by me, this experiment is under strict control. I never lost other packet. I only lost one. Okay, so it will still keep on telling you that, hey, some guy is lost. I still tell you that the sequence number is 2897, but with an update in the SACK port. SACK port, I tell you that, hey, I cache more things now. Okay, as simple as that. So this is the 14 packet. It is up to 8689, and it is supposed to be responding to a packet 11. Okay. Now remember, both end knows about this. Both end knows about this. So when server send out one ACK, and then why there is a row gap here? Let me delete it. Duplicated ACK number 1, duplicate 2, duplicate 3. Immediately, it will trigger the client. Now remember, if the client receives duplicated ACK, it will trigger the client immediately send out a fast switch transmission. Okay? Now, how can I know it's fast switch transmission? Let me copy all the necessary data first. It is a 15 packet. 15 packet. It is a data packet. What is the length? It is a 1448, still 1448, but the sequence number is 2897. 2897. It is a sequence 2897. Suddenly is forget about its pipelining. Okay, it suddenly roll back to a very old sequence number. It's because it received 3 duplicated acknowledgement and immediately trigger fast switch transmission. It means that, hey, this is a small problem. Let me patch it. Okay, patch it means retransmission. Retransmit, all the data is supposed to be lost. So what is the data supposed to be lost? 2897 sequence. Now this is also 2897. Okay, I just patched the problem. And how about the 16 packet? 16 packet, what is the direction? What is the direction? Okay. 16 packet, now it is from the server to the client. And what is data length? It's 0, so it's a plain ACK. Now this plain ACK have an acknowledgement number. Switch it. 16, length 0, so it's a plain ACK out. Let me copy and paste here. Okay. And what is the SACK data? It is up to 10137. 10137. Okay, so supposed to be answering the 13 packet. Why I know about this? Okay, because you can do a very simple counting. 8, 6, 8, 9 plus 4, 1, 4, 4, 8. These two numbers add together, supposed to be this number. Okay? So after the fast transmission, well, actually, because the network is so quiet, so it's firing extremely fast. When this fast transmission sent out, maybe it is just right before this duplicated acknowledgement sent out. So it still have SACK part, but I said that before, the fast retransmission counter, okay. So the fast retransmission counter here will be reset after the fast retransmission is sent out. Okay, so don't be afraid that, oh, will I trigger another wave of fast retransmission? No, you just reset it. Now, what is the 17 packet? 17 packet supposed to be another data. Suppose, let me see whether it's a data or not. It is from, oh no, it's not a data anymore. Okay, it's supposed to be a 2 ACK sending back to back. Okay, so very interestingly, this is of length 0, but suddenly it said that ACK is 10137. Length is 0. ACK is 10137. So what is the meaning? What is the meaning? It is a reply to which packet? Huh? Which one? Huh? 15, right? It is a reply to 15. Okay, do you know why? It no longer has a gap in the entire TCP flow. Because when this come back to the server, it patched the hole, it is the only hole, then it will tell you that, okay, I now start to accept a bigger number. And why is bigger number? Because it's a bunch of data already cached in the server. So it suddenly becomes this number. Okay? Wow, very good. I mean, not very good. I mean, there is a bunch of work, okay, have been done. And after all bunch of work have been done, is fix the hole and explain all the things that I taught in the lecture. Now, what happened next? What happened next is only a few packets before the termination of the flow. Okay, only a few packets. I don't need to record anymore. So what are the few packets? Again, one more data. And this data is funny. This data is only length 3. Okay, I write a 5. 5 data. I send out 5. Okay, now say goodbye. Now how about this is a 220 to 1. This is a client to the server. I send out 5. Then another ACK. Another number that I sent because I set up a fake protocol there. Then suddenly I trigger four-way handshake. Okay? I trigger four-way handshake. Now tell me what happened inside the four-way handshake. Let me record it first. Now supposed to be the start of the four-way handshake is a packet 21. Okay, you can see this packet 21. It is triggered from the client to the server. Client to the server, it is a fin. And why is an egg? Okay. Now why I say that why is there an egg? Look at the PowerPoint here. Okay, the PowerPoint here will tell you that well the four-way handshake is actually a fin and an egg, but not fin egg. Okay. Now this is the problem. The problem of TCP. TCP always acknowledges to something. Okay, no matter there is a real data traveling. Okay, so it is just like hidden rule that when I said the first fin is actually you cannot avoid having an egg also. But this egg is not the special egg. What is the meaning? Special egg is usually plus 1. Okay, so let's check whether this egg is normal egg or special egg. Hey, where's the pop? Oh. Okay, so this egg is actually, let me roll it up. Okay, this is the egg number here. Oh, no, not this. This is the first guy, the first fin egg. Okay, the egg is ACK number 1. So why is it ACK number 1? It's actually triggered by the client to the server. And when the client sends an egg to the server, it means that I acknowledge your data flow in another way. But the server never sent any data to the client. Server never sent data to the client. So this offset will never change. It's always start with the first offset 1. So it means that it's not a special egg. It's 1. It's not special egg. So it means that I acknowledge your server to client data flow. Okay. So that means that I can safely remove this question mark. So it is only a fin. Now what's next? I have an egg. I have an egg sense. Now the egg is sending from which direction? Is from Oh, I click on the wrong guy. Okay, this one. Okay, the 22nd one. Okay, the 22nd one. What is the direction? The direction is IP 198 to IP 220. 198.220. It is from the server to the client. Okay, so the server to the client answer ACK. Okay, so what is the ACK number now? Let's check. The sequence number is 1, no problem. And here is 10146. 10146. Okay, but you have to check whether this is accidentally on purpose adding 1 or not. You have to check the fin sequence number. So let me roll back to one packet, to the packet 21. Packet 21. Sequence number 10146. 10146 is the sequence number. Okay, so it means that, well, actually, this is not a special act. It's not a special act. Okay? Yeah, this is a very tricky trace. It is not a four-way handshake. It is a shorter version of four-way handshake. Okay? And then another packet sent out, packet 23rd. And the direction, what is the direction? The direction is, did I highlight it? 23rd. Okay. The direction is from, let me look at the IP address, 198.220. So also sent from the server. Now this time is VNAC. And look at the ACK number. ACK number is, here. Yeah, the row lower here. Okay, so it's a 10147. Okay, now can you see this? This is on purposely adding 1. So it means that this is an ACK that acknowledging the fin. So this trace is a little bit tricky, or skip by 1. Okay, you can see that it's actually this 22nd ACK is not acknowledging 21. It is something before it. And the 23rd ACK is actually acknowledging 21 fin. So it is fin act. So it is fin act. That means it is this version. Yeah, this version. Fin and fin act. And you will expect that this later act will also add 1 more to the ACK number. So the 24th. 24th packet, what is the direction? It is from the client to the server by looking at the IP address. Client to the server 220 to 198. So it is the ACK. And what is the sequence number? 10147. What is the ACK number? 2. Supposed to be not 2. Okay? Supposed to be acknowledging, because there is no packet flying from the client from server to client. Suppose the offset is always 1. Now it's on purposely adding 1 more there to identify that this is an ACK to this feed. And that's the end of the trace. Okay? So that's why I tell you that you have to bring your laptop and look at the time. Overrun already. Okay? So, any problem you want to ask?